In this particular section, we are primarily going to process text data. And we are going to use one of the most popular approach, that is distributional similarity based representations. It's a bit complex. Distributional similarity based representations, or in other term it is called word meaning as neural word vector or word vector embedding. What happens here, each word from a complete data set are represented in a multi-dimensional vector space, and those words are distributed in such a way so that the meaning of those individual words plays one significant role during training process. Each similar meaning words or similar behaving words or correlated words are distributed in such a way that two similar meaning words will reside in a very close proximity. As these whole distributions occurs depending on the similarity of the word meaning, so there are different names available for this whole training process or this whole modeling approach. We are going to use the term distributional similarity based representations or word vector embedding or word meaning as neural word vector. Before we jump into our further discussions, there is one phrase, very important phrase, especially for this natural language processing point of view. I've written it here. So if you can read it. You shall know a word by the company it keeps. You shall know a word by the company it keeps. That means, in other term, we can say, show me your friends, I will tell you who you are. So we can recognize the meaning of a word from the kind of company it keeps. Okay, so for example, if I say Soviet, the next term will somewhere come around Soviet Russia, then Soviet something else, because those two are almost correlated to each other, and we have other example as well, but those are very rare. To explain the term which we have used, two of the similar meaning words will reside in a very close proximity. Okay. I have drawn one three-dimensional vector space here, and assume that we are going to train our model to present each of these words in a three-dimensional vector space. In reality, it may be 20, 50, 100 or maybe 300 vector space. But for our discussion point of view, I am going to use this three-dimensional space so that we can understand the basic concept behind it. Alright, so assume that that name of the different months for January, February. January is residing here. So what I'm trying to say is that the February, March and other related months or name of the months will also reside somewhere close to this region. Okay, maybe December, maybe July. In a very close circle, they will reside. On the other hand, the name of the days like Monday, Tuesday, Wednesday, Thursday, Friday, they will also reside very close to this section because that is also related to calendar. So assume they will reside here. Friday, Tuesday, maybe that reason. On the other hand, the name of a country, for example, United States or China or something else, France, may decide a bit away from these sections where the days are residing. But those countries will reside close to each other. US, France, maybe China. In this way, each and every word should be distributed in this multi-dimensional vector space depending on kind of meaning they are carrying. So, I will give little more details on these distributions and their regularity which you get from the training process. But before that, let me explain what kind of modeling we are going to use in this particular class. So primarily there are two kinds of models available. Right now it's popular. One is word-to-wake modeling, and the other one is global vector. So GLOVE in short, word-to-wake and GLOVE. Each one of them carries some advantages and some disadvantages over each other. In this particular class, we are going to discuss about word-to-wake modeling. Let me write down the terms. Word-to-wake embedding. Maybe later I can create another presentations on GLOVE vector representations, but that is not part of this class. In these word-to-wake models, we have two primary algorithms. One of them is skipgram and other one is SIBO or continuous bag of word. Skipgram and SIBO. Again, each of these algorithms are designed to perform some specific type of task. They have advantages and disadvantages over each other. We are primarily going to focus on skipgram model, but I will also try to explain kind of functionality we get from SIBO model.